More dense.
More dense. You can also tell me that it's probably smaller. Most likely newer, because the plates that are less dense are generally the ones that are around longer. So they're older. So then you can tell me a lot of stuff by just looking at this picture. All right. Well, as this plate is over here, it's cold, because it's either exposed to air or it's exposed to water. So it's cooler than, say, the core of the Earth. As it moves and goes down, it cools off. So let's say warm. And then as it gets down, as it passes by the other plate and it comes in contact with the other plate, we're gonna simulate that with our hands. Put your hands together. Now go like this. What happens? Warm. Why are your hands getting warmer? Friction. Awesome. You guys did learn something in chemistry. So it warms up due to friction, and it also warms up because you're increasing the pressure, and it also warms up because you're getting closer to the core of the Earth. So there's multiple reasons it warms up, but it ends up getting hot. It ends up getting hot. Everybody drawing this down? All right, I see some excellent pictures out there. Well, as this plate gets really hot, what's going to happen to the metal and the rock in it?
Students are required to be.
It's going to melt. So it melts. So some of that melting magma will rise. It'll find a crack in the earth and it'll rise up through, or it'll push its way through. And it will form this structure on the surface as it comes up. And then it'll make, like, what does it eventually form? Volcano. Forms a volcano.
Wait, what happened?
We made a volcano.
Well, what did
The magma melted, some of it rose up, came out the plate, and formed a volcano. Other magma will go back down and be recycled. It'll end up going in back into where all the other magma is underneath the ground. They get mixed back up, and it will go back into the earth until it comes up again at some ridge. And then this is an ever-continuing process. And next thing you know, we have this cell, which is called a
cycle?
convection cell.
Mr. But wouldn't that just make another divergent fault? Lava goes up?
Yeah.
Mm-hmm.
This is an ever-continuing process all over the world. Some place you have plate being destroyed, and then at some place it's coming up at a divergent fault. So this is an ever-continuous cycle. So you get this convection cell, and this actually moves along the convection cell. You actually get a movement, and it's almost like a belt on a assembly line, or a, yeah, it just keeps moving, and it's like on a treadmill. It's like you're the plate running on top of the treadmill. The treadmill, or the convection cell, is the wheels of the treadmill, and the plate is you on top of it, or the belt. And then what happens when you fall? Well, you melt. You ever play that game when you were a kid? Can't touch the ground or you melt? Yeah. All right. So this is generally a convection cell, or a convergent plate. What do we have right here? This big V-shaped part? What is that called? It starts with a T. It's called a trench, guys. It's one of your vocab words. Did you say it? I'm sorry, I didn't hear you. And this zone right here, that zone where you have something being subdued, is called a subduction zone. All right. Told you guys you'd be drawing a lot. Okay. Now we're going to look at these three types. Now that you know what it is, let's look at each. So let's look at the first one. Or actually, let's make a guess. I want you, right now, on your paper, you can talk to the person next to you, David, but wait until I give you permission to. I want you to figure out which one of these would make the smallest mountains, which one would make the medium, and which one would make the largest. So make an educated guess really quick. So the smallest put a 1 next to, the largest put a 3 next to. You got 15 seconds. Talk to the person next to you if you need to. Go.
You said the plate that the plate on top was the oldest?
Generally older, yep. How are your drawings going? Do you have yours? All right, stop. I'm going to take a poll now. Everybody who thought that the Ocean Continental would be the smallest plate, raise your hand.
Oh, no, I didn't. Sorry.
Medium, raise your hand. Largest, raise your hand. Wow. Was that you were stretching? Number 2, that's your medium. Good job. Most of the class said that. Continental. Largest, smallest. It is the largest. And then this one is your smallest. All right, so let's explain why now. You guys, I think, understand why, because most of you chose the correct answers. That's awesome. So obviously, oceanic, we can't really see. It's under the ocean. You can use sonar to look at it, but you can't see the after effects. But if you were to look at the topography or what it looked like underneath the ocean, you would find mountains everywhere. They are absolutely everywhere. And they don't get that big. Because oceanic crust generally older or newer crust? It's generally newer crust. So if you have newer crust, there's not as much time, A, for mountains to be formed. B, generally the plates aren't as big. So if I have two small objects hit each other, are they going to create big mountains? So I have two really small objects come in. They're not going to create very big mountains. They're going to be small mountains. So that's why they're the smallest. Oceanic continental, so I have my small oceanic Prius and my large continental semi come in. This one's gonna go under. This one's gonna get like butchered, isn't it? Is there gonna be much damage to this one? Not really. It might be a small little dent. So we're gonna have medium mountains, which a good example of medium mountains would be the Cascades. The Cascades or the Appalachians. Anybody know where either of those mountain ranges are?
India.
Where are the Cascades?
Are they here?
Well, they're near here. They're in California, yep. Cascades are in California. And the Appalachian Trail that everybody wants to hike is?
And the East Coast.
It's on the East Coast. All right. So these are both ocean continental plates. And then we have two semis. Big old semis. Both, actually, let's just say they're both Lincoln Continentals. Get it? Continentals? No? Haha. Thank you. All right, they're both Continentals. They're coming in at about 80 miles per hour. What's going to happen to those front ends? They're going to go up. You're going to get some pretty big mountains on those ranges. And plus, they have a lot more time. These are older plates, remember. So what would be a good example of a continental? Starts with an H. Himalayas. Awesome. All right. So continental Himalayas, which are a really tall, big mountain range, would be a good example of continentals. Continental. All right, so you should be able to fully explain to me what a convergent plate is and give me 3 types and give me examples of each except for the oceanic, because I don't know any underwater mountain chains right now offhand. I should have looked one up, but I forgot. All right, so are we good? Can I erase this?
Yes.
Even my good drawing? Now we have one type of plate or fault left. And you guys actually should all know this one, even though you probably don't know that you know it. But in California is a really good representation of a land one. Anybody think of what it is? San Andreas Fault is the example of a large land one. And this is a transform, or as we call it, a strike slip fault. It's called a transform or a strike slip fault. When we get a transform fault, what we have is we have 2 plates. So I have plate 1. So I know what I'm going to do. All right. So we have 2 plates. Plate 1, plate 2. But instead of running into one another, they slide. So one is going one direction, one is going the other. Hence the strike and slip fault. They're striking and then they're sliding or slipping along one another. That's where the name comes from. Transform just comes from they transform the environment. That's kind of where that comes from. All right, so as these plates are moving, they are creating a lot of friction underneath the earth. You have these huge plates that are grinding. They're creating a lot of friction, and that's where a lot of the earth gets destroyed underneath, and then as that earth settles, it creates earthquakes. So a lot of times, you get a lot of earthquakes from the transform strike strip faults, especially in California. Anybody know where it is in California? All right, if we look at California, we're going to pull a map out again. The San Andreas is right there. That would be the fault. Notice, that is where the 2 plates meet, isn't it? This plate and this plate, that's where they meet. So what's happening is they're sliding. They keep saying that this part of the Baja Peninsula down there is going to just drop off with that part of California. Have you ever seen 2012? You notice that it just kind of, bye. Well, that's kind of the idea behind the transform fault. So the San Andreas is the best example. There's a lot of them underwater too. We don't see them as much. But generally, yeah, you have a plate going one way, you have a plate going another. And they move, they create earthquakes from the movements of the plates. All right, homework. You can shut it off now.